Hey everyone, Mr. Hauk here. In today's video, we start trig verification. Let's go ahead and get started. So we've spent several lessons now learning how to simplify trig expressions using our various identities and formulas. Now we're going to start talking about trig verifications. And basically, when we talk about trig verifications, we're talking about proving that two sides of a trigonometric equation are equal to each other, and we use a lot of those simplifying procedures that we've been practicing to work on one side of the equation until it is equal to the other side of the equation. Typically, we start with the most complicated side, and we use simplifying methods to get it to equal the least complicated side. It's typically what you do. Very rarely are you actually going to work on both sides at the same time. Okay? Now, it is important to note that in order to successfully verify trig equations, we're going to need to use a lot of algebra. So that's going to be things like finding common denominators, factoring, expanding, all the different algebraic skills. Okay? So even though there are some examples here in this video, these are definitely not all the examples or all the types of skills you're going to need to have. Okay? That's where practice is going to come in. Practicing these kinds of problems, practicing different trig verifications, that's how you're going to kind of see the types of examples, or a lot of the examples that you'll end up doing. All right? So let's go through these examples, kind of see how these get worked out, and we'll go from there. So here in our first example, we want to verify that secant of x times secant x tangent, or secant of x plus tangent x, is equal to sine of x plus 1 over cosine squared. So I'm just going to start by rewriting the problem. And for me, in this problem, I'm going to go ahead and distribute the secant of x. And notice I'm working on the left side here. I'm going to try to work on this left side until it equals the right side. Okay? And notice that the right side of this equation isn't necessarily like in simplest form or anything. So we're not worried about simplifying this side so much that it turns into its simplest form, like one trig function or a constant or something. We just simply want to transform this side until it equals sine of x plus 1 over cosine squared. We are verifying that these two are equal to each other. Okay? So again, I'm going to start by multiplying or distributing the secant of x. And when I do that, secant of x, let me go back. Secant of x times secant of x, we get secant squared. Secant of x times tangent, we just get secant x times tangent x. So next, I'm going to go ahead and turn things into sines and cosines. So secant squared of x is 1 over cosine squared. Secant of x is 1 over cosine, and tangent of x is sine over cosine. Notice that here the denominator is cosine squared. Here our denominator will be cosine squared after we multiply. So now we have 1 over cosine squared plus sine over cosine squared. And since they have a common denominator, we can add the numerators together. So now we have 1 plus sine of x equals cosine squared of x. But notice this is pretty much what we want it to equal. I'm just going to change the order of the addition in the numerator, and now we have sine of x plus 1 over cosine squared of x. And that's equal to exactly what we want it to be equal to. So we have verified the identity, and we are done with our, basically it's a proof. We're done with our proof. We have proved that the two sides of the trig equation are equal to each other. All right, let's try some more examples. Here at example 2, we want to verify that 1 plus secant of x over secant squared of x equals cosine of x times cosine of x plus 1. So I'm going to be starting with this side, the left side. I'm going to try to get it to equal this side. So I just like to rewrite the problem. I don't know why I do this, but I always end up rewriting the problem with problems like these. So what I end up doing here is I separate the fraction. I have the secant squared of x. I'm going to keep it as the common denominator. I'm going to split it up as 1 over secant squared of x plus secant over secant squared of x. And notice that if I just simply recombine the numerators, that's what I would get. Okay? The reason I'm doing this is because I can kind of see already that pieces have been separated, so to speak. Okay, especially over here, cosine of x plus 1, we can see pieces have been separated. So I'm taking this fraction, separating it out. I think it's going to lead to something. Okay, Well, 1 over secant squared is cosine squared. And secant over secant squared, remember that secant squared is really just secant of x times itself. So we can see that one of these secants are canceling with the secant up top. Get a 1 over secant x. But we also know that 1 over secant x is just cosine of x. So now we have cosine squared of x plus cosine x. And always keep in mind what you're wanting it to look like. You know, this is getting really close to what we want it to look like. We've got our stuff in terms of cosines. Okay? Notice that both of these terms, cosine squared and cosine of x, obviously they both contain cosine, so I can factor the cosine of x to the outside. And if I factor cosine of x to the outside, this is our result. Cosine of x times cosine of x plus 1, which is exactly what we wanted to verify. So we're done. There's our little end of proof rectangle. We have verified our trig identity. All right, here in our third example, we want to verify that cotangent squared of x times cosecant of x divided by cosine squared of x is equal to 1 over sine cubed of x. Again, common trend, I'm going to start here on the left side. I'm going to work on this until it becomes equal to this. Okay, so I'm proving that these two sides of the trig equation are equal to each other. So again, I always rewrite the problem, don't know why. And what I'm going to do here is I'm going to turn things into cosines and sines. I'm going to decompose the terms. So cotangent squared of x, I'm going to rewrite as cosine squared over sine squared. Cosecant of x, I'm going to rewrite as 1 over sine of x. And cosine squared of x, I'm just going to write as cosine squared of x over 1. I know a lot of students in my class like to do this. It kind of helps visualize the whole keep change flip we'll be doing soon. So when you look at what's going to happen here, since these are multiplying, this 1 over sine of x and cosine squared over sine squared, when we multiply them, we're going to get cosine squared on top. We're going to get sine to the third on the bottom. So I'm going to do keep change flip. Cosine squared of x over sine cubed times, and then we flip this upside down, 1 over cosine squared. Now notice that cosine squared of x and cosine squared of x will cancel since we are multiplying. That's going to leave us with 1 over sine cubed of x, which is exactly what we are trying to verify. And we are done with this problem. All right, in our last example here in the notes, we're going to try to verify that cosine squared of x times 1 plus cotangent squared of x equals cosecant squared of x minus 1. So I'm going to be looking on this side. I'm going to transform it, mess around with it until it equals this side. So there's me rewriting the problem. Notice 1 plus cotangent squared. Well, if we look at our formulas, 1 plus cotangent squared is equal to cosecant squared. Okay, so I keep my cosine squared of x right here. I change 1 plus cotangent squared of x to cosecant squared of x with one of those Pythagorean identities. Next, I'm going to turn things into sines and cosines. So cosine squared, I'm going to leave it as cosine squared of x over 1. Cosecant squared, I'm going to rewrite it as 1 over sine squared. Then, of course, we're going to multiply, so we're going to end up getting cosine squared of x over sine squared of x, which is equal to cotangent squared of x, because we know cosine over sine is cotangent, of course. Now, remember, we're trying to get it to equal this, and you might be thinking, well, it looks like all we did was simplify it down to its most simplified state. However, if we look at our Pythagorean identities, notice that cotangent squared is cosecant squared minus 1. So this cotangent squared of x is going to become cosecant squared of x minus 1 because of the Pythagorean identities. And that's exactly what we wanted to verify in the first place. So we're done with that problem. So again, these verifications are not simplifying. You know, they're similar to simplifying trig expressions because we're using a lot of the same procedures and methods to simplify these things. But at the end of the day, we are trying to verify that these two sides of the equation are equal to each other with a chain of logic, okay? So there's our 4 examples. Honestly, we could spend much more time and do many, many, many more examples, which we'll be doing in class anyway. But this is the basic concept. We're trying to get one side to be equal to the other side through simplifying, through our formulas and identities, and we call this trig verification.